To find the radius of convergence, we typically find the interval of convergence. What the radius of convergence is, it is a measure of how far you can move away from the center of the interval and still have convergence. So basically it's half the length of the interval of convergence. When you're finding an interval of convergence for a power series, you're trying to find out what x values you could replace x with and still have a convergent series. So typically we use either the ratio test, the root test, or the geometric series test to find the interval of convergence. Since this has a factorial in it, I'm going to use the ratio test. So we'll be taking the limit as k approaches infinity of the absolute value of 6 times k plus 1 factorial x to the k plus 1 over 4 times k plus 1 would be 4k plus 4 to the k plus 1 times 4k to the k over 6 times k factorial times x to the k in absolute value. And so let's see what will cancel. The 6's will cancel. This k factorial will cancel with that k plus 1 factorial and leave a k plus 1 in the numerator. X to the k cancels with x to the k plus 1 and leaves an x. Excuse me. And then we have 4k to the k over 4k plus 4 to the k plus 1, which can't cancel because of the difference in the base here. So let's see what we've got so far. That would be the limit as k approaches infinity of the absolute value of x times k plus 1 times 4k to the k over 4k plus 4 to the k plus 1. Okay. Now let's see, is there anything we could do for simplification there? Well, that is, since we're talking about the limit as k approaches infinity, I'm going to break the part that is an x out front. So I'm going to break that absolute value of x out front. So we'll have x times the limit as k approaches infinity of, the k's are all positive, so we don't really have to have the absolute value there. I did keep the absolute value around the x because I don't know if x is positive or negative. But I have k plus 1 times 4k to the k over, now let's see, could we factor this at all? 4k plus 4 is 4 times k plus 1, so that would be 4 to the k plus 1 times k plus 1 to the k plus 1. And so this would cancel with one of those, and we are left with the absolute value of x times the limit as k approaches infinity of 4k to the k over 4 times k plus 1 times k plus 1 to the k. And we can, excuse me, cancel out some of the 4's as well, because that 4k to the k is 4 to the k times k to the k. So I can take that 4 and cancel it with a 4 to the k in the bottom. And so we'll be left with the absolute value of x times the limit as k approaches infinity of k to the k over 4, because I have a 4 to the k here, and I'm going to cancel it with the 4 to the k plus 1 down there. So I'll have an extra 4 in the bottom, over k plus 1 to the k. All right, so that is, if I factor this constant out front, we have the absolute value of x over 4 times the limit as k approaches infinity of k to the k over k plus 1 to the k is k over k plus 1 all to the k. And this limit we can do with our L'Hopital's rules, or we can say, okay, we know this is absolute value of x over 4 times the limit as k approaches infinity of, if you divide k by k plus 1, you're going to end up with 1 minus 1 over k plus 1, just rewriting that fraction after division to the k. And so this limit, we talked about these, it's one of our special limits, slightly adjusted, but it's x over 4 times that limit. Whether you use L'Hopital's rule on it here or here, you're going to get e to the negative 1. And so what we know is that this series converges by the ratio test. Converges absolutely when that limit which is absolute value of x over 4e is less than 1. So that would mean that the absolute value of x is less than 4e. So negative 4e is less than absolute x, and that is less than 4e. So our interval of convergence we still have to check a little bit, but we know it's going to be between negative 4e and 4e because of the ratio test, but we do have to check the endpoints separately because the ratio test doesn't tell us what happens when that limit actually equals 1, which would be at 4e and at negative 4e. So we check those separately, but to find the radius of convergence, it's just half this distance. So it would be 4e. Oh, sorry, that I said interval, but I meant radius there. Okay, and once again, if you wanted to know what the interval of convergence here was, you would have to plug in 4e and negative 4e into the original series and actually use whatever appropriate test you had there to check for convergence of that series. But all we wanted on this one was the radius.